This was a spectacular device. It's an analog computer. This was a device that we wouldn't see again for another 2,000 years, until the 1800s. The Antikythera mechanism was once thought to be a simple relic, but its intricate gears and celestial calculations revealed a genius far ahead of its time. By this point, the mechanism was in a bunch of different pieces. Now, AI has been used to reactivate this ancient device, unlocking secrets hidden for millennia. Could this breakthrough rewrite history as we know it? Ancient treasure beneath the waves. When people think about shipwrecks, they usually imagine gold coins, sparkling jewels, or impressive statues lying silently on the ocean floor. But sometimes, the most amazing finds are not the ones that shine. One of the most surprising examples of this is the Antikythera mechanism. It was discovered more than a century ago near the Greek island of Antikythera. At first glance, it looked like a clump of coral-encrusted metal. It did not sparkle or look especially valuable. Yet, after experts examined it, they realized they were holding something far more precious than gold or gems. The Antikythera mechanism is now known as the earliest known analog computer, and it completely changed how we view ancient technology. Back in 1901, sponge divers near Antikythera found a wreck that dated to around the 1st century BCE. The ship that sank was believed to be hauling cargo ranging from beautiful statues to everyday items. The divers brought up several impressive sculptures, jars, and coins. No one expected a rusty box to steal the show. It was only in 1902 that archaeologist Vallejo Stiles noticed gears in that lump of metal. This was so unexpected because gears are precise mechanical parts, and no one anticipated such advanced engineering from around 2,000 years ago. Over the next several decades, scholars tried to figure out exactly what this strange device could do. It was broken into many pieces, heavily corroded, and seemed impossible to interpret. Some people at the time thought the gears might be modern contamination or that they could have been parts of a clock that somehow got mixed up with the wreck. Over time, however, researchers confirmed that the gears were absolutely ancient. The real question was, why did these gears exist at all? And what did such a machine do at a time when most people imagined technology was primitive? The more scientists investigated it, the more astounding the device became. Radiographs, advanced imaging, and careful study revealed a complex set of gear trains that once turned dials and pointers. These dials were calibrated to show the positions of the Sun, the Moon, and possibly the known planets visible to the naked eye. The consensus developed that this mechanism predicted eclipses, charted moon phases, tracked certain cycles, and may even have shown when major sporting events like the Olympic Games took place. Its intricate and refined nature shattered old assumptions about the ancient world. People realized that knowledge and clever engineering thrived long before modern times. The existence of such a machine, around the size of a showbox, raised new questions about what else the Greeks, and possibly other civilizations, managed to invent. This single device might not have been the only one of its kind, but it is the only one we have found and studied. As investigations continued, the Antikythera mechanism sparked debates, inspired new research, and even led to reproductions to see how it might have worked thousands of years ago. The wreck and early reactions. The shipwreck where the Antikythera mechanism was found is believed to date from the 1st century BCE. This ship might have been transporting various goods from the Greek world to Rome or another large regional center. Statues of bronze and marble were also uncovered, along with everyday items like amphorae, storage jars, and jewelry. These findings indicated a trade route that moved not only practical items but also fine art. Many historians suggest that wealthy Romans had a taste for Greek art, so these statues might have been intended for a mansion in Italy. At the time of the discovery, the Greek government was quite interested in examining the unique relics. The clump of corroded metal, though, did not draw much attention. Most archaeologists and officials were busy with the more dramatic statues and coins. When archaeologist Vallejo Stais pointed out that he could see gears within the corroded material, not everyone believed him at first. A few people suggested it must be a modern piece of equipment accidentally mixed in. After all, the idea that ancient Greeks possessed gear-based computers seemed far-fetched. Clocks and similar mechanical designs usually appear in much later historical periods. As time passed, parts of the mechanism were placed in the National Archaeological Museum in Athens. It sat there, puzzling researchers who dared to think more deeply about its function. A handful of early attempts were made to understand the mechanism, but the technology available in the early 20th century was limited. There was no easy way to see inside it without damaging the artifact further. This forced researchers to move carefully. But the device's complexity kept them fascinated. The more they peered inside, the more they saw small, precisely formed gear teeth. The big breakthrough came decades later when techniques like X-rays and advanced scanning tools became available. Researchers realized the Antikythera mechanism was not just a few gears stuck together, it was a very deliberate gear train with carefully measured ratios. They found inscriptions on the pieces that hinted at astronomical references. The script was Koine Greek, the commonly spoken Greek language after Alexander the Great's conquests. Clues were starting to fit together, and experts began to suspect that this device was used for calculating positions of celestial bodies or predicting eclipses. Inside the Antikythera mechanism, when researchers finally began to map out the interior of the Antikythera mechanism in detail, they found an arrangement of around 30 gears. Some say there might have been more originally, packed inside a wooden box frame that has largely rotted away. These gears were typically made of bronze. Each tooth was carefully cut, reflecting an advanced level of workshop skill. Even in modern times, cutting such tiny gear teeth demands precision. The gears are thought to have meshed in a sequence that let a user rotate a side knob or handle, which in turn moved the interconnected gear sets. These, in turn, move pointers on the front and back faces of the device. By looking at the dials, one could see predicted positions of the Sun and Moon for a given date, as well as possible planetary positions. There was also an eclipse prediction function. A spiral dial on the back appears to have shown important calendars, including a lunar calendar that accounted for leap months used in some Greek city-states. One standout feature is how the device handled the Moon's variable speed across the sky. Because the Moon's orbit around Earth is not as simple as a perfect circle with a uniform velocity, the device used a clever design, sometimes referred to as an epicyclic gearing or a differential gear arrangement, to approximate the Moon's elliptical orbit. This meant that the pointer representing the Moon would speed up and slow down in a realistic way. Achieving this required more than just basic gear-cutting ability. It demanded a strong mathematical understanding of how to represent that motion. Studies over the last few decades also revealed that many of the gears have tooth counts that match known astronomical cycles. For example, one gear has 223 teeth, aligning with the Saros cycle used to predict eclipses, 223 lunar months. Another gear arrangement likely corresponds to the Metonic cycle, a 19-year period that helps sync solar and lunar calendars. These details show how the ancient Greeks combined observational astronomy, geometry, and mechanical craftsmanship into a single device. As experts tried to reconstruct how the front dial was arranged, they concluded it may have shown the position of the zodiac as well. The zodiac was central to ancient Greek astronomy, and linking it with a mechanical dial was a major achievement. The device might also have included references to the Pan-Hellenic Games, especially the Olympic Games, marking them on a calendar dial so people would know when events happened over years.